Force, energy and power, question 19. This time we have got three blocks, A, B and C. Each block has a mass of 8 kilograms. Each block has 4 newtons of friction acting against its movement, and there is a force of 60 newtons pushing block A, which in turn pushes block B, which in turn pushes block C. We're asked for various things, such as the acceleration of the blocks in A part 1. Well, A would equal the unbalanced force over the mass, just like it always does. So this time that's going to be the 60 newtons that's pushing to the right, minus 3 batches of 4 newtons to the left. I love my brackets. My brackets is good. And the mass, there's 3 blocks, they're 8 kilograms each, so 3 times 8 on the bottom. And assuming no boo-boos when working it out, that should give you an acceleration of 2 meters per second squared. Believe it or not, that's the most difficult bit in the whole question. So, A part 2, we're asked for the force that block A exerts on block B. Well, let's have a think. Block A must be moving blocks B and C. Therefore, the mass we're interested in must be the mass of B plus C, which is going to be 16 kilograms. And it's got an acceleration of 2 meters per second squared. So some of you are jumping straight ahead and saying, it's 32 newtons, and I'm going, you've forgotten friction again. So the force of friction for B and C, let's think that would be 4 newtons there, another 4 newtons there, so that's 8 newtons. So that's going to be the force of A acting on B will equal the mass of B plus C times the acceleration plus the force of friction on B and C. So that's going to be 16 kilograms times 2. So you would have been right, the unbalanced force would have been 32, but not the total force, plus the 8. So that's going to be a grand total of 40 newtons for part 2. A part 3, the force block B exerts on block C. Well, that's basically same again, but with different numbers. So let's just do that here. A part 3. The mass of C is pretty obviously 8 kilograms because it told us that in the start of the question. The acceleration is still 2 meters per second squared. The force of friction acting on block C is just 4 newtons, there it is. So we're going to have an unbalanced force, which will be the mass of C times A, 8 times 2, 16 newtons, plus the force of friction on C, which is 4 newtons. So that's going to give us a total of 20 newtons for part 3. In B, the pushing force is reduced until the blocks move at a constant speed. So, here we go. Part B. Constant speed, that's a big clue. Because constant speed means no acceleration. A equals 0 meters per second squared. Which means that the unbalanced force is 0 newtons. Which means that the applied force, app for applied, not app for thing on your phone, is equal to the force of friction, which we had worked out way back up here. 1, 2, 3, 4 batches of 4 newtons. So 3 times 4 equals 12 newtons. And that's B part 1 and B part 2. We're asked, does the force that block A exerts on block B now equal the force that block B exerts on block C? No. Oh, it wants us to explain it. That's because the unbalanced force is equal. Well, it has to be since it's 0. But the friction force isn't equal. And that means if the whole package of the 3 blocks stays together, the frictional forces not being equal at each of these joints between each of these blocks means that the forces exerted on A onto B and B onto C can't be equal because the frictions are not equal.